These days, we live in a world where we're encouraged to eat more and move less. With obesity levels spiralling out of control, there's growing evidence this overloaded environment is sending our brains and our appetite into overdrive, morning, noon and night.
It's the thinking about food. It's the exposure to food. It's subtle, unconscious cues that we are now surrounded with. They're the seed that gets planted in the brain to start the whole reaction to be driven to eat a particularly pleasurable food.
Our seemingly increasing appetite for high-calorie, high-fat foods has in the last few years been given a name by scientists: hedonic hunger. At its simplest, it's eating for pleasure. And with so much of this sort of food freely available and cheap, it's no wonder more and more people are struggling with their weight. But new and breakthrough scientific research is starting to explain just why we keep on grazing our way through the day, in a way that proves there's much more to it than a simple lack of willpower or overindulgence on our part. This research has discovered a mechanism in the brain that actively drives our appetite for these sorts of foods. And this discovery is giving us a huge opportunity to look at our weight loss approach in a whole new way. To understand it, however, we need to go back a few decades to the discovery of the underlying survival mechanism that triggers animals and humans to start and stop eating.
The original science, as it relates to eating and body weight, goes back to about 1954. A guy by the name of Elliot Steller proposed a theory called the homeostatic model of eating. And essentially what it showed, and it was done in laboratory animals, is that the hypothalamus, which is part of the brain, was kind of the central location of where things happened, and that signals were sent out from the hypothalamus when food was needed, and blood sugar rose. That person would be told, okay, you've eaten enough, you can stop. Blood sugar would go down, and then that would send signals to the hypothalamus again saying it's time to eat. And the theory was that this mechanism of controlling eating to be at a body weight, which is essential for survival of any species, was centered in the hypothalamus and really focused around blood glucose.
However, there was one thing that scientists weren't able to explain using this homeostatic model of eating. If this was the mechanism designed to help humans maintain their body weight for survival, why didn't it stop them from overeating and gaining too much weight for good health? The homeostatic model alone hasn't been able to explain why a person could feel full after a large meal, and yet want to eat more at the sight of a delicious pudding. It couldn't explain why humans eat at the same, regular times of day that often bear no relation to the need to eat. In the past, most traditional and credible diets, including our own, have focused on psychological states like comfort eating, stress eating, lack of willpower, and negative thinking to explain why people ate more than they needed. And offered psychological tips like managing thoughts and feelings to take control. But these haven't made the difference in helping combat the modern-day rise in obesity levels.
The idea of comfort eating or emotional eating does not explain obesity. We can say that perhaps we're a little bit more stressed than people were 100 years ago, but they had stresses too, and it doesn't all mesh up, it doesn't all fit together nicely. Technology has certainly advanced over the years, and we now have the ability to look and see and measure aspects of what's going on inside of the body physically that didn't exist before.
The technology Karen mentions has in fact transformed scientists' understanding of what drives our appetite when we're not eating for survival. Through the development of functional MRI scans, they can take a look inside the human brain to see what's happening when our appetite is triggered by the sight, the sound, the smell, or even the thought of highly pleasurable, highly palatable, and highly calorific foods. Those foods that are all around us much of the time.
We're going to put you in the scanner.
The chain of events this hedonic hunger reaction sets off triggers an urge to eat that not only looks identical in brain scans to the urge to eat driven by our survival instinct, but most significantly, it feels the same too.
The response appears to be independent of that physiologic, I haven't eaten for 12 hours, therefore my body needs to eat from a homeostatic point of view. But those signals that are released and the response to those signals are identical. So in other words, if somebody says that they have just eaten a little bit before, but they're very intrigued by ice cream and ice cream becomes available, they will have a physical reaction as if they have not eaten for a long time. They'll be thinking about the food. They'll want to eat the food. They will be driven to eat the food. They may start salivating. Their stomach can rumble. All of those signs that you usually or used to think, oh, well, that's because you haven't eaten, happen because the brain is seeing that desired food and is sending signals to the body to eat it.
So the new science shows us that the sensations that drive us to eat food don't just occur when our bodies genuinely need refueling. The influence of pleasurable, palatable, calorie-laden foods can also trigger exactly the same urge to eat sensation, this time driven by hedonic hunger. So why are our brains hardwired in this way when it seems we don't actually need to eat? Researchers believe hedonic hunger forms part of a secondary or backup survival system that evolved in our earliest ancestors.
There were times when they had to eat more than enough in order to survive the future. Think, if you will, the harvest is in the fall and the winter's going to be lean. So there became a requirement for humans to develop a system where they would be induced to eat more than they needed in the moment in order to survive in the future. Nothing is more essential to survival than body weight, so it makes sense that the body would have a main system and then a backup system.
In spite of the fact that we're surrounded these days by so much food everywhere we turn and live in an environment that encourages us to be more and more sedentary and burn fewer calories, the human body hasn't been able to adapt quickly enough and switch off the hedonic hunger reaction. Every time we're confronted by highly calorific foods, whether it's consciously or unconsciously, this can still spark a very real urge to eat. But rather than making us victims of our environment, this new science of hedonic hunger is helping us look at weight loss in our overloaded food environment in a new way, and also how to help our members lose weight with a new, simpler focus. In doing this, we will be the first major weight loss organisation to factor this new science into a weight loss plan. Through our new programme and our service, we'll focus less on psychology and much more on our new 360 approach to provide them with all the tools and tactics they need to make their environment work with their weight loss, not against it. But does it mean Weight Watchers got it wrong in the past?
We know now with these new discoveries in the areas of hedonics to really shine the light on environmental cues, on the creation of habits that work specifically in terms of reducing or managing hedonic cues. And so it's not that Weight Watchers has been wrong in the past, it's that it's been broader. And as always, if there's anything about Weight Watchers, as new science is discovered and validated, we bring it into the program to help our members be more successful. And just as we found in terms of ProPoints, that the macronutrients affect fullness, now we've got hedonics and we have this whole brain thing going on that we didn't know about, and we're able to develop more specific tools that combined can help our members be more successful. So wrong? No. More knowledgeable? Yes.